All right, so today we are going to talk about summarizing data, summarizing data, and also we will make our first plot. So be ready with your R Studios open. And it's not going to be any new data set, it's going to be the same empty cars data set that we used previously. And towards the end of the session, or maybe our next session, we will also start to use the iris data set, which is a flower related data set. So for today we are still going to use empty cars data set. So whenever you get any data, you will have to follow a series of steps. So first you have to make sure that all your data is properly put in a data structure. You may choose a data frame or a vector or a matrix or any data type you find appropriate for your type of data. And it depends on whether your data columns are all numeric or whether they are different types, whether you have factors, if you want to see the data in particular levels, you have to use a factor, and you'll have to make it a factor. And if you have characters and numerics, it's better to use a data frame instead of a matrix. A matrix will be used when you have all numbers and you have to perform matrix operations. And the second step is you ensure that all your variables um, are are of the right type. So what I mean by this is you have to make sure that all your variables, all the numbers are in numeric format and not character format, and all your characters are characters and all your factors are factors. So let me show you one example right after the slide. But let's just go on to the next step, which is you have to check that all the values are being processed correctly. So you don't have, so if you're using statistics, then you have to make sure that there are no NAs that are available in the data set. You'll have to remove those if they are present. And so let's get started on working with the empty cars dataset. So the empty cars dataset, we have looked at this dataset in most of our previous sessions, but we never went into depths of what this dataset was. It's basically a fuel consumption data for 10 different cars or 10 different design points from 32 cars available in like 1970s data, and it contains 11 variables, and most of them are numeric. And some variables could be converted into factors, but you'll have to look at how many values they have. So how do you decide whether a particular variable needs to be a factor or just numeric? Based upon number of values it has. I'll show you that example in just a minute. You start by discovering how many unique values there are in that particular vector. So you will have to get a table with the number of unique values present in every column. So if you recall the apply family of functions that we went through in the previous or the one before, so in those sessions, so the apply family of functions can apply one particular function to every column in a data frame, or depends on what you give it. So if you pass it a data frame, it's going to apply that particular function to every column in that function. So in this line of code here, I'm using the sapply function and passing it the empty cars data set, and I'm giving it a function. So what is the function? You can either form this before this line over here and name that function, they name that function with a give that function a name, or you could directly write it here as a shortcut. Most Mostly what you do is, if you have just one line of code in a function, then that's how you just write it. So what this entire line is doing, it's going to get the number of unique values in each of these columns. So let's just go back to our RStudio and load the empty cars data set, and now I have it in my environment here. And let's just look at the top few rows in the empty cars data. And this is what you see. You have all these columns. If you want to get the column names, just type column names of empty cars, and you will see how many columns you have. You have MPG, cylinder, disp, HP, and others, right? And you have the different car names as the rows, and most of this, all this data is actually numeric. But you have to, in order to get unique values of each of this, right, you could use the unique function. You could use the unique function. You could call empty cars, and you'll have to run it on every column, right? So these are the unique values in empty cars data set for the MPG column name. So if you want to get how many it is, then you will use the function length and then ask how many unique values there are. So you see that there's 25 unique values in the empty cars MPG column. So if you want to repeat this for every column, you should either write a for loop, looping through every column and calling this unique function, or you can use the sapply family. It's going to shorten your code and it's easier to use. So let's do it the long way now. Let's just name the function as a unique function and write our function within this. So if you remember how to create a function, we have to write the keyword function and pass it an argument x. And now I'm going to write the same thing that I used over here, length of unique of x. So length of unique of x. So this is that's going to be my function, and I'm going to run it. Now my function is stored in this unique function. I'm going to use sapply and use it for empty cars dataset, and then give my unique function. And when you run this, you see that it will automatically give you the unique number of values for every column there is in the dataset. So in this example, I have on my slide, I just gave the entire function here. But for beginners, since it's more confusing code, you could create a separate function and then give that function name over here. Or instead, you could just paste the whole function instead of the function name. So what you're getting here is the number of unique values in each column, right? So when do you decide to convert a particular column as a factor, or when to use it as a numeric? Usually what we do is, if we have more than 10 values, it's meaningless. It's probably meaningless to convert it into a factor because it's not categorical data. Like here, what I can see is cylinders. Cylinders, there are only 3 unique values. And let me look at the total dimensions of the empty cars data set. So we are having 32 rows, and in the 32 rows, there are only 3 values for cylinders, which is probably a categorical data. And similarly, what we see is for this VS and AM and gear and carb are probably categorical values. But again, it depends on the meaning of these columns. Like cylinders is like um, it is, you can categorize a car based on how many cylinders it has. So similarly, you'll have to look at what those columns are, what the purpose of those columns are, and then you make a decision of whether you want to convert it into a factor or let it be numeric. So if you recall the advantages of having a factor, you will have basically it's for categorizing your data based on that particular column name. So you can categorize based on that particular column name and only if you want that kind of categorization. It may be if you want to draw plots, separate the MPG, separate the number of cars based on cylinders, and then you would want to convert that particular column into a factor. Otherwise, you can let it remain a numeric. So what we do, so we'll have to first format your data into um, into into a numeric or a factor format. So what I'm doing over here is I'm using a specific function called transform. So transform, what it does is it takes into account whatever columns you give it and transform it according to the other parameters you gave it. Suppose in this example, what I have is I'm passing it MPG, which is the one I'm passing it the cylinders, and this is the transmission. AM is the automatic or manual transmission, and the 10th column is the gear, the number of gears. And I'm going to transform these 4 columns into numeric or factors. If you want to, if by default, if you don't mention anything, it's going to take all these columns. If you don't, suppose if you end your function over here, it's going to take all these columns and transform it into numeric values. But if you want to transform particular columns into a factor, you will have to mention that. So remember the ordered factors that we went through when we were dealing with factors. If you want to if you want to order your categories, such as in the gears you have 3, 4, 5, and it's an ordered, basically more gears and less gears. So there is a natural order to the number of gears. And similarly, you could put an order against the cylinders too, if you wish. But here I didn't use that. I just changed the gear into a factor. So remember, the way of creating factors is to use the factor function. You pass it the column or the vector that you want to convert it into a factor, and then you have other parameters like labels. Labels, you could, if you don't like what it has, then you could rename it and relabel it based on your shorter names. So I'm having these labels over here, calling it auto and manual. So this is I'm changing the AM column into a factor. And similarly, I could use the factor function here and change gear and add another parameter of saying order is equal to true. If you remember back from our factors session, you could create an ordered factor by putting a parameter in the factor saying ordered is equals true. Or this is another shortcut where you can use the ordered function to create an ordered factor. So I'm using this transform function, putting all this data and converting it into factors or numerics. And if you see the structure of cars now, you will be able to see that and since I assigned this transform to a new variable called cars, this new variable will have just the columns that we placed within empty cars. So if you look at the structure of this new data structure that's created, you will see just the 4 columns that we included within the empty cars. So we have MPG, cylinder, AM, and gear. And remember, we transformed the gear and AM into factors, and that's what you will see in the structure over here. AM factor with 2 levels, auto, manual, and then it has a bunch of numbers. And similarly, what you have is gear, and it's an ordered factor with 3 levels, and the ordered factor has to set some natural ordering. So it has set the 3, 4, 5 ordering of levels, and then it has a bunch of values. So the same thing, you could use this transform function to transform any data into factors and numeric. If you don't transform it into a factor, by default it's going to convert it into numeric. So any questions about this? All right. Okay, so let's discuss some continuous variables and what you can do with it. In order to calculate the mean and median of any particular data, you can use those functions. Remember, this was done in the very first session, but I'm just repeating it here because we are going into plotting things. So this is kind of important. So you could use the mean function to get the average of any data set, and you could use the median function to get the center point for any data set. So median is basically, it orders the values and picks the middle value. And in order to get a representation of how spread out your data is, you could use these variance and standard deviation calculations. So standard deviation is just a square root of variance. So you can calculate these two using these functions, var and SD, and pass it that column or any vector. So this is one thing that I just touched upon, but it's more important here since we are going into box plots and how to plot box plots. So it's important to understand the concept of quantiles when we are going to plot box plots. So a quantile is just a part of data when you divide 100% of the data into 4 quarters, then each of those groups is called a quantile. So at 50% of the data, you call it a median, which means you're exactly dividing your data into 2 halves, and that dividing point is called the median. And similarly, if you use a scale of 0 to 100, the 4 quantiles would be 0 to 25, 25 to 50, 50 to 75, and 75 to 100% of your data. And you can also use min, max, and range in order to find how your data is spread out. So in the case of MPG, if you use the minimum, it's going to give you the minimum value, maximum will give you the maximum value, range will give you both values. So just quickly, if you want to check the range of any particular column, you can use this. If you want to check the range of all columns, then you put your range function within sapply, and you put your range function over here, and you can see the values for every particular column. So quantiles, quantiles are basically division of four groups, dividing your data into 4 small groups. So if you want to find quantile of any column, you use the function quantile and give it the column name. So what I'm doing here is giving quantile, using quantile function and giving it the MPG data, and it's dividing my MPG data into four quantiles. So 0 to 25. So 0%, that means which is going to be the minimum, which is the minimum of the MPG. It's going to put it here, and the 100% is going to put the maximum data, and it's going to divide the rest of the points based on 25% of data, 50% of data, and 75% of data. So whenever you run any statistical methods, or even like mean, median, variance, standard deviation, you should make sure that your data doesn't have NAs. So you can use this parameter na.remove within mean, median to remove na.remove equals true. You can actually give it within the function to remove all the NAs and calculate the exact average. Otherwise, it's going to also give the result as an NA if you have NAs within your data. So you can describe categories based on different measurements, like you can have ranges, you can have distributions. And the one thing that I want to talk to you about is you can get so for getting distributions, that is what we are going to cover today. But there is also a quick way of getting a tally of what values you have in your data by using a function called table. So this gives this tallies how many of one particular value there is. I think I talked to you about this, but here it's important just to get a frequency of the number of values. Suppose if I'm using table function on the automatic manual transmission column, we can get a tally of how many automatic vehicles there are and how many manual vehicles there are. So this is going to be the same as an array, and that's returned by the table function. And you know the class variable, the class function, that if you use the class function, it's going to say what data type that particular variable is. So it's going to list it as a table class. So it's a table class. And similarly, you could okay. So to know the proportion of each values, like you have this one, you have 19 automatic cars and 13 manual cars. If you want to know the proportion, what is the meaning of a proportion? What is 19 in comparison to the total number of cars? So what percent of cars are automatic? So the proportion or percentage is somewhat similar. And so if you want to calculate the proportion of these cars, what you can do is you can take that table variable and divide it by the sum of the values, which means what you're doing in this result is you're dividing 19 by 31 or 32, which is the total number of cars, and you're dividing manual cars 13 by 32, and so you will get a proportion of these values. Or you could do this calculation by yourself, or use a function called prop.table and pass it the table. It's going to automatically calculate for you the proportions. Excuse me. So now we're going to talk about how to plot a histogram. What is a histogram? So histogram is the hist is the function that you will use to create a histogram. A histogram is nothing but it's a plot to show what frequency of particular values are present. It counts the number of values. Basically, it's going to put it as a tally plot. So I'm going to just show you an example here. If you use histogram and then plot the MPG column of it, you have this parameter called colors. It's COL, which represents colors, and then you have a whole color palette within R, which you can type in the help and check what colors you have. So here I have gray, but you could you could have any other color over here. So let's just take a minute and take away this one thing from today's class of how to plot a histogram. So use the function hist, give it the empty cars data set, and give it any particular column mpg, and change the colors to whatever you want. So do it right now and let me know in the chat window if you have done it. So once you run this, the plot will show up in the right hand side, plots over here, and then you have an option to zoom. You have an option to zoom here. You have an option to export it in as an image or a PDF, and you have an option to change the sizes and have a high resolution picture, or you can even copy to the clipboard. So right now I want you to just try this one function of creating histograms and let me know in the chat box when you have done it. Okay, wonderful. So this is one important function that I wanted to cover today. And now, so this is something very common. You will need it. Making histograms is something very common that you will need for most of your data projects in R. So a histogram is nothing but it's the frequency or the number of cars falling in each of these bins. So what we are saying here, what this plot says is within what cars fall between 10 to 15 miles per gallon, between having the mileage of between 10 to 15. In this bin, it means that there are 6 cars in this bin having mpg values between 10 to 15, and between 15 to 20 there are 11 cars. So that's the tallying plot, and it's called a histogram. And you can change it. There are very different parameters within this hist function. You can change the labels of the x-axis, the y-axis, by using other parameters called xlab, xlabel, ylabel, and you can find it on your own. So you know where to go to find more help on these. Go to help and type in hist, and you will get a list of all parameters it has. So it has a ton of parameters like probability, you can see frequencies, you can set the breaks, you have this x limit, y limit, to be able to set the scale for x-axis and y-axis, and you have labels, you have mean, so you can change all of those. And there are a ton of others. So if you want to just quickly take a look at what works, then you can try the examples first over here. Try just one of these examples, then you will find the utility of using those parameters. So there are lots of examples. Usually the examples that they list over here, they try to list for most parameters that they have talked about over here. That means most parameters that the function can use. They usually have an example for everything. So you could try and explore that. And so there's another parameter here which sets the breaks, where you can break the data, but it always have to be logical. That means when we have an MPG ranging from 10 to 35, you can logically not make 6 bins. So R is going to override that for you and make it 5 bins. But you can specify the number of bins you want or the number of bars you want over here. So when you want to set breaks, suppose if you don't want, if you don't like what R has done by default for you, like breaking it into 10 to 15, 15 to 20, so it's putting a break at every 5 mpg values, right? So you can create your own breaks. You can give it a set of values. So here what I'm giving it setting as breaks is 5, 15, 25, and 35. So it's going to break at that particular value. So it's starting from 5 to 15, 5 to 15, 15 to 25, and 25 to 35. It's going to create 3 bins, and it's going to tally accordingly. So this is there is another function which calculates the density or a proportional model of the chance of any particular value belonging to that bin. And this is the density is going to, the y-axis here is going to change. It's not frequency anymore, but it's density. So when you calculate the density of any function, it's basically probability values of having a particular value fall in that bin. So the density function calculates this, and if you try to plot that, it's going to plot density on the y-axis, and then you have the numbers on the x-axis. So why I'm showing this is it's not that, so density is not really not widely used, but what I'm trying to show you is you can overlay this plot on a histogram. So here is what I sorry. So here is how I overlay the two plots. So you first draw the histogram using the hist function, you draw it, and then if you want to add anything if on top of that plot, you will have to use this function called lines, and then you give it that density plot, the plot. So it's going to draw this wavy figure on top of the histogram. So just to overlay one plot over the other. So usually in practice, what we have to do is create box plots and mark the data as dots. So for purposes like this, we will have to overlay data points in, say, a scatter plot or any plot. So when we draw one plot and want to overlay something on that plot, we use this function lines. And so it becomes clear in our future sessions how to overlay one plot over the other, but this is just a start. So unfortunately, I will have to stop my session over here, but I hope you have gotten a chance at least to get started with the plotting. And any questions so far?